to radians. Okay, I want to make sure I'm in radians. And that way, when I do, for example, the 2 times the cosine 0, I actually get 2. And if I do 2 times the sine of 0, I actually get 0. So, how about if I plug in pi over 2? Okay, it's not cheating. Make sure that you can do it. Okay, because when I plug in pi over 2, I end up getting, in this case, 0 and 2. Now, the problem's a little bit different. If you're trying to analyze this on your own, the next thing you want to do is you want to make a graph. So take the plunge, make a graph. If you're a little scared to do it, I would say that it's all right to take a risk, because all you're doing is plotting these 2 points. All you're doing is plotting 2, 0 and 0, 2. Now, a couple things. This is your initial point. This is your terminal point. Promise, because that was the beginning and the end of our interval. Now, remember, we're trying to draw a graph. And so definitely I want to start at the terminal point. But if I just draw a straight line, I'm missing some of the big picture of math. Big picture of math is that these points were created with trig functions. Trig functions relate to circles. And so just that type of prior knowledge would say, can't be a straight line. I know it's just 2 points, but prior knowledge says that if it involves sine and cosine, it has to be a circular graph. Now, look what we just graphed. That's right, we didn't graph a circle. We graphed a quarter of a circle. So, when it comes time to convert, I need to do a little thinking about this graph. What I mean is I can think to myself, wait a minute, I did graph something that was circular. I will need x squared plus y squared. It does have a radius of 2. So x squared plus y squared equals 2 squared, which of course is 4. Here's the thing. X squared plus y squared equals 4. That's a full circle. That defaults to a full circle. We need to make the comma. We need to make the additional statement. And so now it's time to say what part of the circle. Now you say, Mr. Young, it's like the first part. Yes, but what kind of values are these? They are values when x is positive and y is positive. And as soon as I say x has to be greater than or equal to 0 and y has to be greater than or equal to 0, I've now described the original parametric equation. Okay? And that's analyzing a parametric equation. Now, at this point, what I would do is we would go through a few more concrete examples of analyzing a parametric equation. I just kind of want to take a little stop, and I want you to notice what we've done every time. Okay, because now we're gonna show you that we can do this with some different kind of problems. A few more examples, and then the last thing we're going to do is we're actually going to do this backwards. We're going to do it backwards. All right. So, you've seen a parabola. You've seen some circles. Is everything a parabola or a circle? Well, no. Okay. Some parametric equations are what are you thinking when you see these kinds of equations? Are you thinking of anything mathematical? Yes, that's right. These equations are linear. Now, if you say, well, how am I supposed to know that? There's nothing nonlinear about them. There's no exponents. There's no trig functions. No square roots. We're only talking about basic multiplication. These Parrish equations are linear. Now, I want to also add this closed interval. And I just want to make sure you understand, you don't make that up. That's part of the problem, okay? That is the restriction on the parameter. Now, what that allows us to do is allows us to pretty quickly make a table of values. I do mean that honestly at this point. We've seen a number of these. It's always going to be a table of values with 3 variables, t, x, and y. Yes, 0 should definitely be in your table, and 1 should be in your table. Now, if you say, should I put any other numbers in here? Well, don't put any numbers greater than 1, okay, because it has to be less than 1. Of course, don't put any negative numbers in, because it has to be greater than 0. Could you put a half in here? You could. But I want you to become the student that realizes that we don't need 3 points, because if it's linear, you just need an initial point and a terminal point. So go ahead, plug 0 into these equations. 3 minus 0, 2 times 0. Go ahead, plug 1 in. Plug 1 in. 3 minus 3. Plug 1 in. 2 times 1. 3, 0 is my initial point. Label it. 0, 2 is my terminal point. Label it. Now, when you connect the dots, we've already talked about that prior knowledge says that this is linear. And so when I connect the dots, I'm able to draw a straight line. Now, I realized I forgot something in the previous problem, and that is I forgot the direction. The direction is always part of, is always part of a parametric analysis. So we'll put the direction arrows in this one. I forgot them in that quarter circle that we did a moment ago. And you can go back and add the directions to that quarter circle. Okay, so this is our graph. It's already labeled. Now what we're going to do is convert, or to use some other language, eliminate the parameter. I just want you to realize that to eliminate the parameter means to get rid of the letter t. And when we get rid of the letter t, we turn the problem into Cartesian. Cartesian is x and y. All right, now, how in the world am I going to get rid of the letter t? Okay, well, in the previous problem, we did some hokey pokey with x squared and y squared. And I think the problem before that, we did a little bit of like substitution. It all depends on the problem as to what you're going to do. A problem like this can be solved for t. So I want to say to you that if you can solve for t, you should, because that means it's going to be a simpler substitution. So the first problem, if I solve it for t, this isn't anything new, adding and dividing. So some simple inverse operations, but I don't want you to be surprised when you get negative 1/3 x minus 1 equaling t. How about solving the other equation for t? A little bit easier, right? Y equals 2t. Obviously, you're just going to divide by 2. So we have 1/2 y equaling t. And so we get to the substitution step. If negative 1/3 x minus 1 equals t, if 1/2 y equals t, then we know that these two would have to be equal. So we're going to say that they're equal, but we need to have some awareness that it's not written in the form that would be more standard. In other words, I need to solve this for y. Now to solve it for y means I'm going to multiply everything by 2, right? And if you multiply both sides by 2, you get negative 2/3 x minus 2 equals y. No more t. That means we eliminated the parameter. But guess what? It's wrong. What? Why didn't I delete the video? Why am I showing you something that's wrong? Because I want you to realize that the only reason it's wrong is because it's just not right yet. It's just not a full line. Listen, back in Algebra 1, when you guys were graphing y equals mx plus b, you always drew a full line, right? But this is not a full line. So all we gotta do is say that this equation's fine, but when x is between, okay, so notice that we're taking the numbers that are on this graph. In other words, an x value is 0 to an x value of 3. And we're saying that this equation's right, just we need x to be between 0 and 3. Okay, and now we have completed the parametric analysis. Okay, we're going to do one more problem. But we're going to do it mainly on the calculator. That might be good or bad. You should have a graphing calculator. If you don't have a graphing calculator, you can use Desmos. But the graphing calculator is going to be preferred for this class, so make sure that you sign one out from me. Or maybe you decide that it's time to go own your own. Trig functions again. I know. Here's the thing. When you see sine and cosine, it's just functions that take angles off a circle and turn them into points. Okay? I want to show you how the calculator can do that. In other words, the calculator is going to graph the points. Now, your calculator has some other modes. And on a graphing calculator, if you push the mode button, the fourth line down, you can change to polar mode. Polar mode is going to, when I push the y equals screen, give me, why did I say polar mode? My fault. Parametric mode. Parametric mode, the second choice, PAR, when I push the y equals button, is going to give me that new setup where I have 3 variables. I can say x equals 2 sine of t. Now, how did I get that t? I push the variable button. The variable button is right underneath the mode button. It says x, t, theta. Okay, so I can type in my parametric equations. Okay, now remember, I had to change the mode to parametric mode. That was the second choice. That way, in the y equals screen, I get x equal and y equal. Now, there's one more thing we need to think about. It's the window. And I've seen kids, they don't like the window. They're confused what it means. Honestly, folks, the window is just the types of numbers that show up on your graph. We've been given a lot of information here. We've been given that our t is going to only use numbers from 0 to 2 pi. So that's the minimum and the maximum. I can type in t minimum 0, t maximum 2 pi. It turns out when I type in 2 pi, it changes it to a decimal. Now, the t-step is not the new dance that we do for gym class, the t-step. The t-step is actually the amount of numbers the calculator is going to plug into your calculator, or should I say the interval of those numbers. You really can just leave it as anything that's small. 0.1 is usually fine. That'll work. Now, the x min and max, the y min and max. That's just the x and y numbers that are going to show up in my graph. Sometimes you don't know what they need to be. I would propose to you that if you're looking at these numbers, you should have some knowledge that those are going to be kind of how big and how wide my graph gets. So it's a standard window. -10 to 10 is plenty of space. Now, when we push the graph button, watch the direction of the graph. Also watch where it starts and any other observations. Did you catch all that? So when I graph this, I want to see where it started. Now, yes, it did start at 0, 5. Yes, it did go in this direction. Okay? I don't know if you think that that seems backwards, but the truth is that is the direction. And then, of course, it comes back up. Now, you want to realize that this is where the graph started and stopped. So it's the initial point and terminal point. You always want to label that. You also want to realize that this graph is not a circle. It's not a circle, but it's circular. Okay? All trig functions will make graphs that, all trig functions that use sine and cosine will make graphs that are circular. So what are we going to do for the equation? Okay, well, what we're going to do is we're going to observe that this thing is an ellipse. Okay, now some of this takes some prior knowledge. There are some things in math that, because something we learned yesterday, we can apply it today. In this case, it might have been something you learned last year. If you didn't learn it last year, you can still approve of it today, because this is an ellipse. And the equation for an ellipse, by the way, here's our graph. We did on the calculators, there's not a lot of work to show, but I do show the graph, I show the sketch. And now what we're going to do is go over here and convert. Now, to convert, we're going to use a little fact. And the fact is that x squared over, over a squared plus y squared over b squared equaling the number 1. Well, that's always the equation for an ellipse. This is the equation for an ellipse. Now, honestly, the only thing we really need to figure out here is what the heck is A and B. And without going through the whole lesson from last year, A and B refer to distances on a major and minor axis. Okay, now because A is with x, it's going to refer to this x distance. Notice that it's being measured from the middle. And so that's actually half of the minor axis. But the important thing here is that we just realized that A equals 2 is the distance from center to point on the axis. So I can actually plug in here 2, meaning 2 squared, which ultimately will change to 4. B is with y. And so this is a y measurement. It's vertical. Notice it's the distance, or that it's a distance that's on this long axis, which is actually called the major axis. But all we really need to know is that B is that length, which is 5. Now here's the thing. You can simplify this equation. You can do the math. And you get x squared over 4 plus y squared over 25 equals 1. Now, I don't like showing students things and just saying it is what it is. That's the right answer. If you're saying, yeah, I don't really know why, it's a lesson from last year that goes over that form of an ellipse. Okay? When you do it in your assignment for a grade, you guys will find out that you can refer back to this example. Okay? Not every problem we do is going to be an ellipse, but if there's an ellipse, you can refer back to this example. It'll be the same idea. All right? Now, there's one more problem that makes up this second day, and it's honestly a problem that we're going to do backwards. Now, doing a problem backwards is actually trying to create the parametric equations. Instead of eliminating, we're going to try to create. We call that finding a parameterization. Pretty big words. I want to make sure I'm spelling it right. T-R-I-Z. Finding a parameterization. In other words, actually trying to come up with the parametric form of the problem. Okay? Now, we're only going to do this for a line segment. Only going to do it for a line segment because, quite honestly, it would be a whole different ballgame if we tried to do it for a parabola or for an ellipse, something like that. So, to find a parameterization for a line segment, we kind of have a little rule. Listen, I'm not big on rules. I'm big on you understanding why. But sometimes there are some rules that will get us to the why, and we can come back and figure that out. So any line segment will always fit the x equals x sub 1 plus at, y equals y sub 1 plus bt for 0 less than or equal to t less than or equal to 1. In other words, any line segment will always have that parametric form. Now, here's the thing. We just need to find 4 things. We need to find x1, we need to find a, y1, and b. We need to find those 4 things. Okay? Let me show you how we can do it. It's actually, I know it sounds kind of complicated, but once you get some numbers, you start to see how you can plug in these numbers. So let's say we want to parameterize, a line segment with endpoints of -2, 3 to 5, 1. I gotta tell you, I'm big on making graphs, and we can make a graph. We can make a graph of this. But I find that for this problem, since it's so new to students, if they graph -2, 3, and if they graph 5, 1, and draw the line segment, they're tempted to find the slope. They're tempted to find the y-intercept. And although that's good math and your algebra teacher will be proud of you, we're actually trying to find all of this. We're trying to find x equals x sub 1 plus at, y equals y. So I'm not saying the graph's a bad idea, but it might not be helpful this time. -2, 3. What is that? You say, Ms. Naylor, it's the initial point. Good. I say to you, it's x and y. It's x and y. Now, interesting. What can you do with x and y? What can you do? Yes, you can plug it in. You can plug it in. This actually goes back to fundamental algebra ideas, where if you have x and y, you can plug it in for x and y. Interesting. Notice that I put boxes around x and y, not any of this other stuff over here. All right, let's plug in -2 for x. Let's plug in 3 for y. Now you'll notice that I am leaving an empty space for t. Now we get a little bit into understanding the big idea of parametric equations. Because the question I'm going to ask you is, what is t? When x equals -2. When y equals 3. When you're at an initial point. What is t when you're at an initial point? That's right. T is 0. Now, as soon as I plug in 0, something happens. Something happens. I get part of my goal. I get x sub 1 equaling -2. I get y sub 1 equaling 3. Don't get blown away by the problem. Remember, I told you we need to find x1 and y1. We are halfway there. x1 and y1 are -2 and 3. So guess what? All we gotta do is find a and b. You know you gotta use your other given, so we're gonna use 5, 1. We're gonna plug it in. I'm gonna plug in 5 for x. I'm gonna plug in 1 for y. Now I'm leaving some things out because you should be saying, but Mr. Naylor, I know what x1 and y1 are. Should I use them? Yeah, you should use them. You should also be plugging in, or maybe I should say substituting in, -2 for x1, 3 for y1. Have you already filled something in for t? Now be careful, the question is what t value goes with this endpoint. What t value goes with this endpoint? The t value of 1. And as soon as I plug in the number 1, we have the ability to solve this equation for A equaling 7. We have the ability to solve this equation for B equaling -2. Now, my final answer here is taking this information and in some sense recopying my formula. So my formula says that x will always equal x sub 1, which in this case is -2, plus 7 times t. Notice that I'm putting 7 in for A, I'm still using t. Y equals 3 for y sub 1 minus 2t. And if you're saying, do I have to write 0 is less than t is less than 1? Yep, because that restriction is what matches with these a, b, x sub 1, y sub 1 values. And this is my parameterization. Now, if you have a little bit of extra time, you could graph that parameterization. And although I said the graph may not have been helpful, what we just want to realize is that we don't want to be confused by the graph. Now we're going to check with the graph. We're going to check. And so I can type in -2 plus 7t. I can type in 3 minus 2t. And in my window, I want to carefully go from just 0 to 1. I change my t min and max to 0 to 1. And I get a line segment. Okay, it's actually the same line segment that we did look at before we started the problem. And that is finding the parameterization. We have now officially finished lesson 1.4. What this means that you can start working on your book assignment. Your book assignment matches the assignment schedule that is posted and is something that you now can slowly start working through. And please feel free to refer back to this video at any time.